Hello, everyone. So today, this week, we're going to be looking at the Rocky Mountain Arsenal from environmental catastrophe to urban wildlife refuge. And this kind of feeds off of what we talked about last week with the restoration of Lake Apopka. This is another interesting case study of how scientists and land managers go about restoring a really kind of messed up habitat. So where is the Rocky Mountain Arsenal? It's about 11 miles from downtown Denver Central, but Denver is a city that's really sprawled. So in a lot of ways, the city has kind of expanded out into this whole area, and it kind of abuts the wildlife refuge now. And since obviously Colorado is far from where we are in New York, I wanted to make sure you kind of knew where this was. So on the inset map up here, you can see we're right in the middle of the United States. Colorado is that square state that's hard to identify sometimes when you see it on a map. And the Rocky Mountain Arsenal is right on the edge of this big Rocky Mountain range. So the brown here is all really tall mountains. The edge here is the Great Plains. So it's a really interesting spot with the mountains in the background, but it's actually in the Great Plains ecosystem. And so here are some pictures of what this would look like if you went there now. So it's now the Rocky Mountain Arsenal National Wildlife Refuge, and it's on these open plains with views of Denver, downtown Denver, with the Rocky Mountains in the background. But why is it called an arsenal? It's because of it was used as a military base. And that's kind of why we're talking about it in wildlife toxicology, because there's a really long story of the different contaminants that were on this land. So your book starts out the chapter on the Rocky Mountain Arsenal with this quote, which is just absolutely wild. But they said, an Army commander at the arsenal reportedly called a 1 square mile section located in the center of the arsenal the most contaminated square mile in the nation, or even the most contaminated square mile on Earth. Although to our knowledge, the quote has never been verified, it has become part of the folklore of the arsenal, regardless of its accuracy. So even if it isn't the most contaminated square mile on Earth, there is a history of major contamination in this area. And to understand, we've got to go back in time, right? So the history of the arsenal in 1942, the U.S. Army purchased a 70 square kilometer area to use to manufacture chemical and incendiary weapons. So this was during World War II. At the end of World War II in 1945, they still continued to use this area. Through the late 1960s, the Army was manufacturing chemical warfare agents here, and later it was used to demilitarize obsolete chemical agents and bombs, which usually meant just firing them off or somehow getting the chemical out of it and putting it into a lake or burying it or something. During this time, they also had enough property that there was some overlap, and then Shell took over. So from 1952 to 1982, Shell leased part of the land to manufacture pesticides. So now we've got two different things going on here. The Army making chemical warfare and bombs, and Shell making pesticides in the same 70 square kilometer area. And a question you may be asking yourself is why in the 1940s did they decide to put a military arsenal in Denver, Colorado? It was kind of went from this was agricultural land to a major military base. The thinking at the time was because it was in the center of the United States, it was far from the threat of enemy aircraft who couldn't travel that far inland. At that point, this was a while ago, but it was also close to major railroad lines so that we could move whatever product was being manufactured out. It was also close enough to Denver that there was enough infrastructure like water and electricity and a lot of people around. It was close to a major city, so there was skilled labor nearby to work there. And they had enough land to include several, kilometers of undeveloped habitat so that the public wouldn't be able to see what was happening at the major site, which was a concern for the military. So it had enough land that they could put fencing around it and keep people out from really far away. So what was it like? What was it like when this was being used as a military base? So I'm going to embed a video as another comment here, and I want you to watch it. It's about 10 minutes long. It was done, I think in the 80s was where some of this footage was from, when people who worked at the base were still alive to tell their stories. So it's kind of an oral history of the people who work there. And it's talking about the history of land before and while it was a military base. So as you watch this video, think about the time frame when the arsenal was built, especially since we seem to kind of group things in this class based around when Silent Spring came out. Think about when all this was happening at the arsenal. And think about, put yourself in their shoes. So these people were in the middle of World War II. And based on the people telling their stories, do you think they were worried about environmental contamination of the surrounding area? And then just to kind of put this in your head, because it's concerning to me that I couldn't find a video that addressed that the first people on this land were Native Americans. Think about how this video is a story of post-European colonization in Colorado. And if we were asking Native Americans to kind of talk about the history of the land, how would they frame the issue differently? So take your 10 minutes to watch this video and then move on. So hopefully from watching that video, you get an idea of the people who are working there and kind of the thought at the time. So then when you see this list, I mean, it is upsetting to think about how many chemicals were being used in this area. So the types of agents and munitions made by the Army at the arsenal: mustard gas, lewisite, phosgene, napalm, white and red phosphorus, sarin gas, VX. Overall, they estimate over 136,000 tons of contaminants were manufactured there. And I do think it's fair to say they were not overly careful about what was getting out into the environment at this time. The war effort was a more pressing issue for them. And it was pre-Silent Spring, so people weren't necessarily even thinking about the fact that we could impact the environment at this point. Then when part of the land was leased to Shell, I said that pesticides were manufactured there. So the list of pesticides, aldrin, dieldrin, chlordane, endrin, all of those were from your list of the dirty dozen, right? The persistent organic pollutants that we talked about in a previous module. They're all banned now in the United States. And then even atrazine was being used. So remember the atrazine issue from the Dr. Hayes case study. The full list of everything that Shell was manufacturing there is too long to write. And obviously, like, their goal wasn't to release this. They weren't trying to release it, but in a lot of the manufacturing, there would be spills and different things that they would then get out into the environment. So overall, 24,000 tons of pesticides were likely manufactured there. So what do you need to know about all the different chemicals? Just be aware that it was a lot. It was a lot and a lot of different things. The major persistent ones, so the ones that will stick around in the environment for a long time and that killed wildlife later on, were the organochlorine pesticides. So these are those persistent organic pollutants that then, later on in the history was when we had the Stockholm Convention and people talking about we need to get these out of the environment and stop using them because they're so dangerous. But those are the ones that kind of became the consistent problem at the arsenal in the future. So by the 80s, everyone had left. The Army had stopped manufacturing things there. Shell had stopped their lease. And so after everyone left, it was an area full of disposal pits, landfilled, and open basins filled with, and this is another quote from your textbook, a toxic stew of liquid waste. There was documented, once people started looking for it, contamination of the soil, groundwater, surface water, sediments, and even air. That was how polluted this area was, that there was just actual contamination of the air if you walk through. And I think it's important to remember kind of the layout of this land. It was designed so that the core of things were happening in the middle, and there was this buffer zone around the outside. Now, originally the buffer zone was put in place so that people couldn't see what was going on the military base. But now it's kind of a good thing because there was some area that was uncontaminated. and because all of the activities were kind of happening in the center here. So they started seeing wildlife mortalities once they started looking for it, right? So the earliest document is in 1952. 1,200 ducks died. It kind of marches through the 50s. Some of this, might have had more mortalities, but they weren't being recorded. The Fish and Wildlife Service here estimated 2,000 ducks per year, maybe 20,000 over a 10-year period. In 1964, they started realizing maybe some of this was an issue. They started removing some of the contaminated sediments from lakes. Still saw some duck mortality. And then you can see it's kind of like in the 80s, it was just sort of, from 1981 to 1987, we think under 2,000 birds died. But I think a lot of this was that it wasn't being super properly documented. By 1989, they started moving some of those contaminated liquids that were filling these ponds over to storage tanks, because that was kind of the issue. There was so much contamination just in the water and in the surface water that ducks would come in and land in what they thought was a pond, and it actually had really high levels of contaminants. So something that we haven't touched on in our timeline of things that have happened in terms of environmental regulation is the Comprehensive Environmental Response Compensation Liability Act, often called CERCLA. So this was put in place in 1980. So think back to your timeline of Silent Spring in the 60s. Now we're starting to understand we could do some major damage to the environment, which hurts both wildlife and people. So you may have heard of this as Superfund. This is the law that puts in place designating things as Superfund sites. It establishes prohibitions and requirements concerning closed and abandoned hazardous waste sites. It importantly provided liability for persons responsible for releases of hazardous waste at these sites. So it's saying that if you contaminated a site, you are liable for it. You have to pay damages. And it established a trust fund to provide for cleanup when no responsible party could be identified. So the Superfund is that now we have money set aside to clean up places when they need to be cleaned up, even if there isn't a responsible party that can be tracked down. If there is a responsible party, they are tracked down and go through the litigation to have to pay for cleanup. And as research was done based on this CERCLA or Superfund litigation, the major cause of mortality was traced mostly to the organochlorine pesticides like dieldrin and aldrin. So these were part of those dirty dozen POPs. And it's important to remember, again, that these are fat-soluble and long-lasting in the environment. So these are ones that will persist for a very long time. Also of concern for this area was that there were many threatened or endangered species living in this area. So remember, we've talked a lot about how when an endangered species comes into play, it triggers a whole bunch more protection by the federal government and money being funneled towards it. So not only was CERCLA in play where any place that was contaminated needed to be cleaned up, but now there was also potential litigation because of threatened species. So there were bald eagles, ferruginous hawks, and burrowing owls. These are burrowing owls here. I'll include a video link, which I would say is optional, but it's so fun to see these guys in real life. They are some of the cutest little owls. They actually do nest in burrows in the ground. They can fly, but they generally are found walking around on the ground. And this is even more of an aside, but I just love owls. We don't have burrowing owls on the East Coast, so you won't be able to see them in your yard or anything like that. But we do have these guys, the northern saw-whet owls, and they are the smallest, cutest little forest owls that you'll ever see. Hard to actually see in real life because they're very small, very secretive, and live in the forest. But I don't know, it makes me happy to know that this little nugget is in the forest around me around here. There was obviously a ton of research that went on in the arsenal in the time while all this was going down. I want to highlight one particular study, which was on great horned owls. It was called The Productivity and Survival of Great Horned Owls Exposed to Dieldrin. And so in this study, they use radio telemetry where they can actually put a little tracker on the bird. Now we can have satellite trackers and things, but these weren't satellite trackers. These were ones where you had to get close to the bird with an antenna and be able to count where it was. And they were able to track who survives. And they were looking to compare contaminated versus uncontaminated areas of the arsenal and see if they could see higher mortality in the contaminated area, because all of that shows kind of this effect, right? So we talked about the difference between exposure and effect studies, but this was really trying to get at that effect of survival on the owls in this area. So the objectives of this study, or the goals, were to evaluate the number of offspring produced by great horned owls in contaminated and uncontaminated areas, determine the relationship between dieldrin and in the owl's tissue and overall survival in both juvenile and adult owls, and use these results to help design future biomonitoring approaches. So we're going to get into the importance of the fact that they were tracking both juveniles and adults. So I wanted to make sure you understand owl and most bird life cycles. So for the most part, birds kind of pair up. They build a nest. The female lays eggs in the nest, and then the female has to incubate her eggs for a certain amount of time. Once the eggs hatch, for birds like this, that the nestlings don't have feathers yet, they stay in the nest for a period of time as well. So the female will continue incubating them. Once they're hatched, though, the parents have to bring food back and forth. Owls have another little interesting thing that they do, which is called branching, which is what these photos here are, where at some point they get big enough that they leave the nest, but they're not really capable of flying or taking care of themselves for any amount of time. And they literally just sit out on a branch. The parents keep bringing them food, and it's kind of their way of getting used to the environment before actually going out and flying around and catching their own food. So all of that for owls is kind of considered the nestling life stage. And then there's a point where, before they're fully grown adults, where they have to figure out how to find their own food. This is what we kind of call the juvenile life stage. Different birds call it, or different periods of time. It's usually that time after you're a nestling to, the first year of life. Most birds can breed, once they're 1 year old. So we consider them not juveniles by the time they're breeding for the first time. But in that time period, after their parents have stopped helping them and to the time where they try to make it through their first winter to breed, they're considered juveniles, where they're not quite great at everything, right? They're trying to figure out how to be a bird, and they can be pretty dumb. So back to the study, they were doing owl surveys, and they also captured birds. They were able to take plasma and tissue, so blood collection, and then they did radio telemetry, which I said they put a little backpack on the bird and are able to follow it around using a radio signal. And through this, they were able to track survival of both juveniles and adults. They also monitored the levels of dieldrin in the soil, prey, plasma, and tissue samples. So they could use the castings. So if you ever dissected an owl pellet, they could collect those from different places and analyze how much of the pesticide was in there. They also would collect mice and everything else that the owls were eating and actually sample that as well. So the main findings of their paper were that productivity did not differ between uncontaminated and contaminated areas. Productivity is like the number of babies that they're producing. On both sites, the adults were having the same number of eggs and having the same number of nestlings. And they found that adults in the uncontaminated area only had slightly higher survival. And those that did die, it was during times of nutritional stress, like during reproduction. So when the birds are breeding, especially during that nestling or branching stage, the adults are really rather stressed because the nestlings are not independent at this point. They're growing and they need a lot of food. So they're constantly out hunting and bringing food back to their nestlings. And so they were stressed. They were stressed nutritionally, and they think that the dieldrin was mobilized during that time. The juveniles overall had much worse survival. and that those that died from the contaminated sites died during dispersal. So this is that point where they become juveniles and they're on their own. They often have to disperse away from where their parents are living and find their own territory. And so this is another moment of nutritional stress. And the idea was that Dildren was mobilized here as well. So what do I mean by mobilized, and why would Dildren get mobilized during times of nutritional stress? So this all relates to the fact that those organochlorine pesticides are all fat soluble. So it means that they can get, ingested and then brought into fat and kind of locked away in the fat. But if that happens, when fat gets burned, they remobilize. So they come back out into the bloodstream and they can cause toxicity later on. So these birds can be bioaccumulating over their lifetime. Dildren, it gets kind of stored away in their fat. And then at times of nutritional stress, when they burn that fat to be able to have energy, they kind of get this huge dose of Dildren at one point. So it's a weird thing where they could be taking in Dildren at a low rate. It's getting locked away in the fat. And then during these nutritional stress moments, they'll be mobilized. So, so just think about that. The two times that were most stressful, right, were juveniles dispersing away from their parents. They don't know what they're doing. They're trying to find food. They're burning through their fat reserves. And then again, when the parents were reproducing and having to take care of their offspring. So two very important times in the life cycle of a bird is when they were getting this like huge dose of this pesticide. So that paper and, a lot of other work was done to determine where the contamination was worse, what needed to be done. And then they decided, okay, well, we need to clean up this area. We obviously can't leave it. There's so much contamination and the wildlife are so affected. But how to start cleanup? So like, what methods can adequately characterize 70 square kilometers of potential contamination? What are the appropriate remediation goals given the proposed future land use? What would count as cleaned up? Like, we don't think we're ever going to get this back to zero, but we need to figure out what would count as cleaned up in this example. And there's many stakeholders to talk about. So the Army was potentially at fault. Shell, the EPA came in because there's endangered species and other things in there. The Colorado Department of Public Health and the Environment. So the state agency was also involved. So there was a lot of different groups that were concerned about this and a lot of discussions that had to go on to figure out how were they going to clean it up. And what they ended up doing was something called a risk assessment. So remember that they knew that the contamination was in water, soil, air, and biota. And so they needed to come up with a way to decide who should be monitored. And so, especially for the wildlife in particular. And so they ended up with 3 categories of representative species: avian predators, like this bald eagle, species with special feeding niches. This was a lot of ducks and waterfowl because of the fact that there was all that open water with heavy contamination. And then the prey, so mice and rabbits and things like that. So what they did is, with all those groups together, decided these are the 3 groups that we're really concerned about continuing to monitor across this big area. And they could set up kind of a sampling strategy for them. And so I think it's important to remember that they were monitoring a small subset of what we would call the entire prairie food web, right? So they did have some of the kind of prey items. They were looking at different birds, which aren't even on here. But there was a lot of other things that they could have studied. But partially, they just needed to know, for things that are sampleable in this area, what is their level of contamination? It would help them understand where the worst contamination was on the kind of big area to focus their actual cleanup efforts. So they also had to think about how the contaminants were moving through the food web. So they also surveyed soil invertebrates, but these themselves are often insensitive to toxicity, but anything that eats them might be sensitive. And again, that relates to this idea that it's fat soluble, so that anything that gets taken up by the soil invertebrate will get moved up the food chain or biomagnified. The other issue that they had was thinking about, what are we going to do if there's more than one contaminant? Because there was such a long list of contaminants in this area. It wasn't like if we think back to the South River Mercury study, we knew mercury, that's what we're looking at. But this was like so many different contaminants that they could look at. And they also need to think about the fact that if we just test for dieldrin and endrin and aldrin, the effect of having multiple of those in the environment may be additive. So two chemicals both might be below their impact threshold, but given together may add up to have a big effect. But it's really hard to develop thresholds for. You can have this much and this much, this additive idea. And then an even bigger concern was that the effects could be multiplicative, which means that it's not just that they add on top of each other, they multiply when they come in contact together. So if you're exposed to two of these chemicals, you're at really higher risk. So through a lot of research, a lot of studying these different groups they assessed, getting a lot of chemical analysis done, they were ready to start cleanup, which is classified as remediation. So this is when they're actually trying to clean up those contaminants in the environment. They decided most of the research had focused on the organochlorine pesticides, so that's what they were going to focus on first. They had to come up with what soil concentration could be considered sufficient to ensure that no future adverse ecological effects could occur. So basically, they're saying, what's a safe dose? We don't believe we can get this to zero completely, but we want to get to a point where we don't think anything's going to be harmed in this area. So this was based not just on the soil concentrations, but also how the different foraging guilds and different animals that could potentially live there would interact with these concentrations. So they looked at feeding behavior, feeding rates, feeding preference, trophic transfer, bioaccumulation, and biomagnification rates. There's a ton of work that went into this to try to understand, okay, this is the level that we need to clean this up to. And remember, this is not necessarily being done out of the kindness of their hearts. This is because there are laws in place that say you need to remediate if you are the cause of these chemicals in the environment. And the most important remediation actions, which there was a ton that went on, but mainly they maintained groundwater containment systems so that the groundwater from this area, which was contaminated, couldn't get into the public water supply. They demolished structures that won't be used, which was most of the chemical manufacturing areas. And they actually had to excavate millions of cubic meters of contaminated soil because there just wasn't any way to clean these persistent pesticides out of it. So they actually dug it all up. So now if you go, you won't see this kind of small city of chemical plants. It is all returned back to kind of the environment at this point. There's a few remaining buildings, but they had over 200 buildings demolished. They actually did recycle some of it, and then they had to excavate a whole bunch of soil. So they excavated all this soil. What did they do with it? The issue, this is a continuing issue when we're dealing with contaminants in the environment, is there's nowhere to put it. There's nowhere safe to put it because you don't want to put it in someone else's area. So what they decided to do here was create landfills. So they were lined on the bottom to prevent leaching into the soil, and then they were capped on the top so that all of that, pesticide held soil was now caught in this landfill and not able to keep moving around the environment. So with all that work, do we just say mission accomplished and walk away? No, even after all the remediation work was done, continued monitoring was necessary. First of all, they didn't sample every inch of soil, so there's no guarantee that all the contaminated soils were removed. They are pretty sure they got to the most heavily contaminated sites, but also pretty much forever, the landfills and the caps and the lining on them are going to be continually checked because these could break down over time. And if the chemicals inside of them are still haven't broken down, they could then leach into the environment. So there is a continuous monitoring plan set up for this area. With that monitoring, they're not just taking samples, they're also monitoring some of the wildlife species. And the two that were isolated as most interesting to study were European starlings and American kestrels. So why these birds? First of all, They're secondary cavity nesters, which we've already talked about in this class, but it means they use nest boxes for nesting, which means they're so much easier to find the nests so that the researchers can get good numbers and good amount of nets. The starling is also invasive. It's a non-native species to North America, so in some ways it's not as bad in people's minds to take their eggs. The kestrel is native, but they are a good surrogate or understanding of all the predators, since they are a small hawk that eats a lot of mammals like mice and rodents. So I said in the end that this becomes a national wildlife refuge. So why? Why did we turn the most contaminated square mile on Earth into a national wildlife refuge? So at the time, there was an economic, political, and social push to make this a wildlife refuge. Partially because so much damage had been done to the environment, it was kind of a way to set aside land for environmental preservation. It also had really nice buffer areas, and remember, in those buffer areas there wasn't any contamination. But by protecting it, this allowed kind of the Denver sprawl, the city sprawl, couldn't move out into this area, and it protected the really nice buffers. I think a part of it was that it actually would be really hard to clean it up for commercial or human use. The idea that anyone would build a house and live in this area seems far-fetched, that anybody would want to live there because of this stigma as the most contaminated square mile on Earth. And the important thing was that even once it became a wildlife refuge, the Army and Shell couldn't walk away. They have to maintain those landfills and groundwater treatment facilities. And they also paid $35 million in the natural resource damages to the state. And this was in addition to the $2.1 billion for investigation and remediation that had happened. So remember, we talked about natural resource damage assessment in the Mercury case study. This is where you have injured the environment in some way and you actually have to pay back money. And so even though it became a wildlife refuge, those companies and, it was basically the federal government, the Army, were held accountable. So once they decided this was going to become a wildlife refuge, not, condos or more city, they moved on to the restoration process. So we talked about restoration in Lake Apopka, but in this case study, it's important to realize that restoration was different than remediation. Remediation was them trying to figure out how to get the contaminants out of the ecosystem. Now they wanted to work to figure out how to bring back the native habitat, or the restoration process. This is also a long and complicated process. Some highlights: they had to move clean soil from other areas, or borrow soil, so that they could have something for native vegetation to grow in. They then had to replant the native vegetation, get it growing, get it looking like a prairie, and then they could start actually reintroducing animals. So they reintroduced bison and black-footed ferrets were some of the kind of notable megafauna that came back that now people can see. But it was a very active project, right? So there was a lot going on that had to be actively controlled while this was happening. And while this was going on, there was a continuous question of what is the reference condition at this site. So some people would say it was restoring it to Great Plains prairie, but other people might think, well, the reference condition was that this used to be agriculture. We saw that in the video, right? Before the Army took over this area, it was people's farms. And so maybe we should turn it back into farms. I mean, you can go back in time and be like, oh, we should have a woolly mammoth on this land. Like, that's the reference condition for pre-human settlement of North America. It's a hard question, and it's something that's debated. I think what was interesting in this case study was that there were researchers who actually asked the public what they thought. And I think this is becoming even more common in science, is that kind of natural scientists work with social scientists to understand, well, what do humans think about this? Like, we need to get some buy-in from the people. And so this was the paper that was written about this, called Examining Restoration Goals at a Former Military Site. And so the two questions that I thought were most interesting were, first, what landscape condition would be most faithful to the Rocky Mountain Arsenal site history? And they asked people what they thought. So, the majority of people, 50%, said uninhabited prairie for plants and wildlife. But then some people, a good proportion, thought this should be a recreational facility. Go down into, Native American settlements, farms, and homesteads. Some people still said, well, most faithful would be chemical manufacturing. But then they asked the question in a slightly different way. What landscape condition would be most natural to Rocky Mountain Arsenal site history? This is where they got overwhelming 72% uninhabited prairie for plants and wildlife. Some still pick some of the other things going down that way. But I just think this is something that we should always consider, is bringing people into it and thinking, kind of getting an idea for what local people think in this area. So in the end, I would say the Rocky Mountain Arsenal is a huge success. It just was a long and winding road to get there. But I use this as an example of when all the laws that are put in place did the right thing, right? It held people accountable. It made them remediate and get rid of the contaminants despite a really high price tag. And then it allowed for restoration and to return it back to a wildlife refuge.